torque on a current loop in uniform magnetic field. Here, north-south poles are shown. There is uniform magnetic field in this direction, and normal of the loop makes angle theta with the direction of magnetic field. This angle is theta, and this PQRS is a loop. Its specifications are given. PQ equal to RS. This PQ and RS are B, and QR and PS. QR and PS are A, and the area of loop will be AB, which is capital A. Magnetic forces on PS on this and this are being equal, opposite, and collinear, and they will act along this line or along the axis of the coil, and hence they will cancel out. And the magnetic forces on PQ and SR being equal and opposite will form a couple. They will be parallel. So let's consider the expression. So we have to find out the torque. Torque will be equal to force times perpendicular distance. So force will be F, which is equal to B I L, and here length of this side on which force is acting is small b, so BIB. Similarly, this will also be BIB. So force will be BI small b times perpendicular distance. So this distance, if this side is A, so this distance will be A sine theta. This side is shown here, magnified view. This is A, so perpendicular distance will be A sine theta. So torque will be BI AB. AB can be written as capital A sine theta. If there are n turns in the loop, then torque will be equal to n times BIA sine theta. We can define magnetic moment M, which is equal to NIA. So this will become MB sine theta. In vector form, we can say tau equal to M cross B. Maximum value of torque will be NBIA when theta will be 90 degree, and minimum value will be 0 because it will occur when theta will be 0 degree. And as far as stable and unstable equilibriums are concerned, when theta is 0 degree, then we call it a stable equilibrium. Stable equilibrium when theta equal to 0 degree. Unstable equilibrium will occur when theta equal to 180 degree. Now, there is one important note. If direction of magnetic field makes an angle alpha with the plane of the current loop, then theta plus alpha will make 90. And from there, this relation NBIA sine theta in place of theta, we will write 90 minus alpha. So tau will be NIBA sine 90 minus alpha, which is cos alpha. Now let's understand these concepts by some examples. So question number 1. The maximum torque acting on a coil of area 0.04 square meter is this much. When the current is 100 microampere, find the magnetic induction in which it is kept. So let's write the informations. Here information given is area equal to 0.04 meter square, and torque is given as 4 into 10 to the power minus 8 Newton meter. Current is given as 100 micro ampere, or 100 multiplied by 10 power minus 6 ampere. So we have to find out B. So maximum torque, tau max, will be equal to N I B A when theta is 90 degree. So B equal to tau divided by N I A. We put the values. So B will be equal to tau. Tau is given here 4 into 10 to the power minus 8 divided by number of turns. Here number of turns are not given. So we assume N to be 1 loop. So 1 into I is given as 100 into 10 power minus 6 times area. Area is given as 0.04. So this will give 10 power minus 2 Tesla. Let's take next question. A rectangular coil of sides 8 cm and 6 cm having 2000 turns and carrying a current of 200 milliampere is placed in uniform magnetic field of strength 0.2 Tesla directed along the positive x-axis. What is the maximum torque the coil can experience? In which orientation does it experience the maximum torque? And second point, for which orientations of the coil is the torque 0? When is this equilibrium stable and when it is unstable? So let's write the solution. Information given is length and breadth are given as length is 8 cm, that is 0.08 meter, and the width is given as 6 cm, or 6 into 10 to the power minus 2 meter, or 0.06 meter, and number of turns N equal to 1000. I is given as 200 milliampere and power minus 3 ampere, and the magnetic field is given B equal to 0.2 Tesla. So let's find out magnetic moment M equal to N I A. We put the values. N is 2000, I is 200 into 10 power minus 3 into area. Area is L into V. So 0.08 into 0.06. So if we multiply, we will get it as 1.92 ampere meter square. This is value of magnetic moment. Now we can find torque. So maximum torque will be equal to tau equal to mb sine theta, will be maximum when theta equal to 90 degree, that is tau equal to mb. We put the values. So m we have got 1.92 into magnetic field is 0.2. So this will equal to 0.384 Newton meter. Now, next point is, for which orientations of the coil is the torque 0, and when is this equilibrium stable and unstable? As I told you, stable equilibrium means theta equal to 0 degree, unstable equilibrium means theta equal to 180 degree, and torque will be 0 when theta equal to 0. So the torque on the coil is 0 when M is parallel or anti-parallel to B. Suppose B is in this direction and M is also in this direction. So this will be stable equilibrium position and theta will be 0 degree. Or if M is in this direction, theta is 180 degree, unstable equilibrium, and still torque will be 0. Now let's take next question. Question number 3. Find the torque on 100-turn rectangular coil of size 40 cm into 20 cm carrying current of 10 ampere and placed at an angle of 30 degree with magnetic field of strength 3 Tesla. So let's consider solution. So we are given n equal to 100. Area will be 0.4 multiplied by 0.2 meter square. I is given as 10 ampere, and here alpha is given as 30. So B is given as 3 Tesla. If you remember, I told you when magnetic field makes an angle alpha with the direction of the plane of the loop, in that case, formula of torque changes to NVIA times sine 90 minus alpha. So it becomes NVIA cos alpha. So we put the values. So it will become N number of turns 100 into magnetic field is 3 into current is 10 into area of the 0.4 into 0.2 times cos 60 degree, that is 1 by 2. So if we evaluate, it will come out to be 120 Newton, which is our answer. Thank you for watching.